Okay, this is 1314. Now we're going to work into section 4 of chapter 3, which is more factoring and completely factoring a polynomial. I'm David Dipple from Lone Star College, Montgomery. Okay, suppose we have a fourth degree equation and k is -3, and the multiplicity is 2. That means it's going to work twice. So we just did the synthetic division twice. So you take your -3, which is your k, your coefficients 1, 8, 22, 24, and 9. And do the synthetic division. Bring the 1 down. -3 times 1 is -3. Add gives you 5. 3 times 5 is -15. Add gives you 7. 3 times 7 is -21. Add gives you 3. 3 times 3 is -9. Add gives you 0. Just means it's a 0. It is a factor. Now, we can do this again. Put the -3 in front. 1, 5, 7, 3, and do it again. Bring the 1 down. 3 times 1 is 3. 5 minus 3 is 2. 3 times 2 is -6. 7 minus 6 is a positive 1. -3 times 1 is -3. Combined gives you 0. So now we have the factors. Again, we did this twice, so it's x plus 3, x plus 3, and then x squared plus 2x plus 1. And this final trinomial will factor into x plus 3 is squared because it's written twice, and this factors into x plus 1, or x plus 1 squared. Now, when you have a polynomial and you want to find out what may work for your k values, sorry about that. I'm doing multiple things here. When you're trying to find your k values, if you have a polynomial like 3x to the fourth, 2x cubed minus 4x plus 4x minus 5. Take the first coefficient, which is 3, we call that q, and take the last coefficient, p, and factor each of those. The possible zeros, the things that may work that are fractions, are the factors of p divided by the factors of q. The factors of the last number divided by the factors of the first number. In this case, +1, -1, +5, -5. That's what makes 5. And what makes 3 are +1, -1, +3, -3. So the only possible numbers we can be dealing with are, if you stack these all up, 1, -1, 5, -5, 1/3, and -1/3. Look at all those. 1s, 1/3s, 5s, and 5/3. Yes, all positive and negative. So those are the possible zeros. Again, you take the very last number, your constant, factor it on top, the leading coefficient, factor on the bottom, and that gives you your possible zeros. Now, to actually check and see which ones do work, we're going to use synthetic division. On the problem that we had before, we're going to try 1 to see if it goes into 3, -2, 0, 4, and -5. So you get 3. 1 times 3 is 3, makes 1. Add gives you 1. Add gives you 5. 5 gives you 0. So 1 is a 0. Then write out the factors. X minus 1 times x cubed plus x squared plus x plus 5. Now you can also, on a calculator, graph and trace, and you will find that it doesn't ever touch the x-axis. So those are all the possible zeros that actually do work. Now we can reverse this process and find the polynomial if I give you the answers. If the zeros are 4, 2, and 0, we can turn that into factors. X minus 4, x minus 2, and x minus 0, or just x. So if I give you zeros, and if they give you multiplicity, it just means we'll multiply them several times. So it's x minus 4, x minus 2, and x. If you multiply these together, x times x, and x times 2, and 4 times x, and 4 times 2. So it's x squared minus 2x minus 4x plus 8. Or if you combine the middle terms, x squared minus 6x plus 8 multiplied by x, you get x cubed minus 6x squared plus 8x. So that is the polynomial of a lowest degree that has zeros 4, 2, and 0. And again, If I have the zeros, I just take the opposites, opposite of 4, opposite of 2, and that gives me my factors. Okay, then we have what's called Descartes' rule of signs, and that tells you the number of positive zeros of a function is the number of sign changes, or if there's a lot of them, like 10 or something, then it may not be all 10 of them. It may just be like 8 or 6 or 4 or 2. You subtract even numbers less than the number of sign changes. Now, for example, if you have negative x to the fourth minus 3x cubed plus 4x squared minus 5x plus 2, we count the sign changes. Negative to negative is not a change. Negative to positive is a change. Positive to negative is a change. Negative to positive is a change. So here's 1, there's a change, and that's a change. That's 3 changes. So you could have 3 or subtract 2, 1 positive real zeros. So the only number of positive zeros according to Descartes' rule is 3 or 1. Now if you want to check negatives, you do the same thing except plug in a negative for x. Negative to the fourth is positive, so that's minus x to the fourth. Negative cubed times a negative is positive. Negative squared times a positive is positive. Negative times negative is positive, and 2 is positive. So first you plug in a negative value and see what happens. Now we only have one change, so there is only one, or possibly maybe only one, negative real zero. So in this case there may be 3 positives, but only 1 negative. So that's Descartes' signs. You simply count the number of sign changes for the positive possible zeros, and to find out how many possible negative ones there are, plug in a negative and then count the sign changes. Now we also have something called bounds of zeros. Zeros can't just be anywhere. They have to be within some boundary on a given polynomial. There are restrictions to how far away from 0, for instance, the x-intercepts are. Now to find that, suppose you have x to the fourth plus 3x squared minus 8x minus 2. You simply add the absolute value of the coefficients. So we have 1, 3, 8, and 2. And so I took the 3, the 8, and the 2, add those together. So you could also take 1 plus the largest, which is 9. So those are your bounds, okay? And then you look at those numbers, it's either 13 or 9, and whichever one is smaller, that's the most restrictive. So 9, positive 9 to negative 9, that's where your answers can possibly come out. So the boundaries on a polynomial, for instance, if you're graphing, you want to find out where it touches the x-axis. If you'll sum up the coefficients, that's one of the possible answers. Another is 1 plus the largest. Okay, in this case, 8 is the biggest number. Add 1 to it, gives you 9. So 9 may be a bound, or 13 may be a bound, or 14 if you add all the coefficients. You take the smallest of those numbers, which is 9. So plus or minus 9 is the boundary that will restrict our zeros in this polynomial.